Just like multiplication is repeated addition, exponents are repeated multiplication. If I write 2 to the 4th power, this is the same thing as 2 times 2 times 2 times 2. 2 is called the base, and 4 is called the exponent. 2 is being repeatedly multiplied 4 times. So if I have 5 cubed, as this first problem is, 5 cubed is 5 times 5 times 5. 5 times 5 times 5 is 125. 6 squared would be 6 times 6. There's just 2 lots of 6. 6 times 6 is 36. Now this one here says the inside parenthesis thing is being squared. So negative 6 squared is negative 6 times negative 6. And that's going to be negative times negative is positive. 6 times 6 is 36. Now this is very different, however. This is not negative 6 squared. It's negative of 6 squared. So in other words, we have 6 as being squared. So we have the negative of 6 times 6. 6 times 6 is 36. And the negative of that is just negative 36. You see how the difference between these two problems? We have a parenthesis. The parenthesis is what designates what's being squared. And here we do not have parentheses. So if you want to square a negative thing, you need to put it inside parentheses. If there are none written there, then that means the negative is not being squared with it, or being cubed, or being to the 4th power, whatever you have. It's only going to be squared or cubed or to the 4th power or any power if it's within parentheses. Make sure you understand that. It's a common thing for people to get wrong. Okay. 6 squared is 6 times 6. 5 squared is 5 times 5. And 3 to the 1 power is going to be just 3. There's 3 one time, and that's just 3. 6 times 6 is 36. 5 times 5 is 25. Times 3. I'm going to use a calculator because it's going to be a big number. Oh, actually, it was not terrible. 2,700. Order of operations says do exponents before any addition, subtraction, multiplication, division. So 4 squared is done first. 4 times 4 is 16. 2 plus 16 is 18. It's still multiplication or exponents first. 3 cubed is 3 times 3 times 3. That's 3 times 3 times 3 is 27. 8 squared is 8 times 8, which is 64. And 2 cubed is 2 times 2 times 2, which is 8. Now we do multiplication division next. So we must do negative 64 divided by 8. Negative divided by positive is negative. And 64 divided by 8 is 8. 27 minus 8 then gives us 19. Okay. 12 minus 5 times 2 to the 5th power is 2 times 2 times 2 times 2 times 2. It's 32. 2 to the 4th power is 16. Multiplication and division is done left to right. We have negative 5 times 32. That's going to give us, I'm not sure, 160. And it's going to be negative. Negative times a positive is negative. Negative 160 divided by 16 is just going to be 10. It's going to be negative 10 because negative divided by a positive is negative. And 12 minus 10 is 2. Okay, this one has parentheses, and that comes before exponents. So 27 divided by 7 is first. That's going to be 4. 4 squared minus 14. 4 squared is 16. And 16 minus 4 is 2. Okay, the inverse operation of addition is subtraction, which is why they are so closely tied together. The inverse of multiplication is division, and so it has the same kind of relationship. What is the inverse of exponentiation, which is what we just did? And that would be roots. The square root, if it's squared, it's going to be a square root. If it's cubed, it's going to be a cube root. If it's the fourth power, then it's going to be the fourth root, and so on and so forth. These are normally done with a calculator because typically they are not very easy to work with numbers. They're infinitely non-repeating decimal numbers. That's the usual for a root. But there are some that can be done by hand. So for instance, if I look at the square root of 36, this is going to equal some number x. What this means is that it's asking what number x times itself equals 36. And this equals 6. 6 times 6 equals 36. Now, because I've specifically stated the square root of 36, we assume the positive. There is actually a second number, which would be negative 6. Negative 6 times negative 6, negative times negative is positive, and 6 times 6 equals 36. However, if the root is stated here, it's asking for the positive answer. It's only when you take the square root of something that you have to worry about adding up, considering the positive or negative answer. For instance, the square root of 81. This is asking what positive number times what positive number equals 81, and that would be 9. The square root of 121 is going to be 11, positive 11. The square root of 400 is positive 20. Okay. Now these are order of operations. Radicals, as these are formally called, roots instead of, they're called radicals. They are done the same time as exponents because technically they are an exponent. So if we have 3 squared times the root of 24, we're going to do both of those at the same time. 3 squared is 9. Root 24, that's not a simple root. We have to actually use a calculator. I'm just going to round this to 2 decimal places. I get 4.90 over 3 times 2. And here we can do the top and bottom. They're always assumed to be in parentheses when you're using fraction bars like this. So 9 times 4.9 gives you 44.1. 3 times 2 is 6. And doing that division gives us 7.35. Okay, the next one. Inside of a radical is parentheses. We have to do that first. 5.2 squared minus 3 times, inside we do 5 squared first. That's going to be 5 times 5 is 25. 52 minus 25. Then we do the 52 minus 25 next. That's still inside parentheses. That's going to end up being 27. And then we have 5.2 squared, and then the square root of 27. 5.2 squared is 27.04. And it's 3 times the square root of 27. I'm going to round this to 2 places again, which is right around 5.20. Now we do multiplication and division next. Negative 3 times 5.20 is going to be negative, and 3 times 5.20 is 15.6. And finally, 27.04 minus 15.6 gives us 11.44. All right, now we have some application problems. Find the length of a side of a square whose area is 184.96 square feet. Now, a square has the same length as width, right? And for a rectangle, the area of a rectangle is length times width, which in other words is going to be x times x, which is just x squared. So if the area is x squared, then to find that area, what we have to do is take the square root. That's how we cancel with that and get x by itself. So we take the square root of 184.96. And in this case, you would have to consider both the positive and negative, but since length of a side of a square can never be negative, it's a distance and distance cannot be negative, we have to have a positive number here. Because you could, like I told you before, the square root, I said x squared equals 36. This actually has two answers, x equals 6 and x equals negative 6. But for our problem, it has to be the positive. It cannot be the negative. So we only care about the positive answer here. I hope that makes sense. All we have to do really here is just take the square root of 184.96. And that gives us 13.6. And that's the length of the sides of the square. All right, here we have the length of a rafter on a shed roof is calculated with the formula. I'm going to write this formula out. L equals h2 minus h1 squared plus w squared, and square root of that. This actually comes from the Pythagorean Theorem. Suppose that h2, which is the maximum roof height, is 13. In other words, h2 here is 13. h1 is 7.5. So let me write like this. h2 is 13, h1 is 7.5, and w is 12. Calculate the rafter length, which is L, and so we have to round to the nearest tenth, and all we have to do is solve this expression here. Again, PEMDAS is always what we follow with. Parentheses first, 13 minus 7.5 is the first thing we need to do. That's going to end up being 7.5, I think. 6.5. 5.5. 5.5 squared plus 12 squared. 5.5 squared is 30.25. 12 squared is 144. 144 gives us 174.25 on the inside, and now we can finally take the square root, which gives us 13. It says round to the nearest tenth, so I see 13.2, and these are all in feet, so the final answer will be in feet as well. Okay, the Golden Gate Bridge is about 1 mile long. Warm day, it expands about 2 feet in length. If there were no expansion joints, then the bridge would end up bulging up or downward, whichever way it goes. And it's asking how high would that be? That's equivalent to just solving this thing here in the radical. This again comes from the Pythagorean Theorem. If you think about the bridge in a very simple kind of diagram, yet you have one end of, like, this is the earth, and then the bridge spans across the water, and then to the other side. On a hot day, it will expand, but it has to expand some direction, and so it'll end up making this bridge bulge out like this instead. So it'll actually bulge up, or it'll bulge down. And all we're doing here is we're asking, in red here, we're asking, what is this bulge? You can create a triangle out of that and use Pythagorean Theorem to find it. That's where this formula comes from. All we really have to do is solve this thing, use PEMDAS and everything, and then we'll be good to go. So the height then, 5280 divided by 2 is 2640. Plus 1 is just going to be 2641 squared minus 2640 squared. We do exponents before addition and subtraction. I get 6974881 minus 2969600. Doing that subtraction gives us 5281. And we get 72.67, and this is going to be in feet. And I checked my work there. I'm pretty sure I'm correct. That means that the height, this height here, would be 72 feet tall. So a 1 foot expansion that can't go anywhere without the expansion joints would end up producing a bulge in the Golden Gate Bridge of 72 feet tall, which would be a huge change. That would be quite terrifying to drive across, if you even could. All right, last problem. We have an electrical resistance of a given length of wire is inversely proportional. So this is an inverse proportional, and we also have, it's not direct, it's not a 1-to-1 proportionality. It's actually proportional to the square of the diameter. That's what this equation is here. You see that A and A are connected, but we have a square on the bottom, and we have B and B are connected, and we have a square on top. So it's an inverse proportionality. That's why it's flipped, one on top, one on the bottom, and we have a square because it's inversely proportional to the square of the diameter. But we're still going to solve this as we would a proportion: cross multiply and divide. So if the length of wire has a diameter of 34.852 mils and has a resistance of 8.125 ohms, so let's say that that's going to be wire A. So this is going to be wire A. Put in black here. So we have a resistance of 8.125 ohms. I'll not write the units. Equals 34.852 mils. A mil, if you don't know, is a 0.001 of an inch. It's just a very small unit of measurement for the US standard units. Okay, what is the resistance of the same length? So the resistance with a diameter of 45.507. And I forgot the squares here. Both of these are squared, the resistances. Or sorry, the diameters are squared. So we have our numbers. Now we can solve this by cross multiplying and dividing. I'm just going to show you the whole operation here instead of actually solving for the numbers specifically. We have 8.125 times 34.852 squared equals 45.507 squared times x. And we just divide this number over to that side, which gives us 8.125 times 34.852 squared over 45.507 squared. That equals x. Now we do the exponents first in order of operations. So 34.852 squared (1214.66). I'm going to round to 3 decimal places. It didn't say in the problem, did it? No, it didn't. The given numbers here all have 3 places. So our answer should have 3 places as well. Right, and in the bottom, 45.507 squared gives us 2070.887. Now we can multiply the top and divide by the bottom. 8.125 times 1214.662. 9869.12 I guess 9. And then doing that division. Now I need 3 places. We get 7, 6, 6. And this is a resistance, which means it is in ohms.